Hello, so welcome to my YouTube channel. So this is the third video of lead code problem related to DSU, disjoint data set data structure. So I have covered two videos I think related to the DSU. One is the count the number of connected component in the undirected graph, and second is the account merge. So if you haven't watched that video, you must watch first. That is no dependency, but you can watch that will be a different interesting video on you will get a better intuition. So let's jump into the problem and first I will read that problem so that you can able to understand what the problem is and how will you solve this using DSU. Okay, so you can search the count the servers that communicate on a browser. You can get the link for LeetCode. You can try yourself. Okay, so problem statement, you are given a map of server center and representing as m cross an integer matrix grid where n means on that cell there is a server, 0 means on that there is no server, and two server are said to be communicate if they are in same row or same column, and return the number of servers that communicate with any other server. Okay, this is one. If you see, they are in no server are in same row or same column, that's why they are in not in communicated with each other, so that's why answer is 0. But in this case all three is connected, means they are communicated because they are in same either in same row or in same column, that's why total number of server are in communicated is 3. Okay, and if you see for this example, these two are connected and these two are connected and these are not, because no server with this are in same row or in same column. So 2 plus 2, there are four server they are which are incommunicated. Okay, so that's the problem. So I have written down your problem with the matrix grid so that you can understand better. So for this one, if you see, these two and these four are incommunicated separately. Okay, so total number of server to be communicated, that is the 6, right? In that case 4. How that 4 comes? So I will tell you. If you see, this cell and this cell are have one, means they means have this is our server, right, represented by 1. So if you see, these are in same row, same column, not same row, but this and this are in same row, and this are in same column, this and this are same row. So all these four are connected either way. So total number of server if you count are communicated, so which is 4. Okay, so if you ever think of applying the DFS over DSU, so if you ever solve the number of island problem, count the number of island where the 1 represent the island and 0 represent the water in a matrix. So if you remember that in that problem, all the island definition was the something else, not this way. Okay, in this case different definition of server said to be communicate is different to the island definition, if you remember, that was the said to be connected, island said to be connected if they are at either they are in adjacent up and down or right and left, so they are contiguous. But in this case these are not contiguous. Only condition is should be in same row, either in same row either in same column. That's the definition. It may not be, it may be a contiguous, it may not be contiguous. Okay, so in this case if you see they are contiguous, so in the if for this example DSU will work, this will give you 4. This one, this one connected group, this one connected, total is 2 plus 4, that's 6. In this case DSU will work, but in this case DSU doesn't work. How? If you see, if you are trying to apply the DSU adjacent uh, neighbor, there is no adjacent neighbor which have one, means which have no like have, there is no server with this cell. Similarly for this, so DFS doesn't work here, and DFS work here. Okay, but DSU work in anyhow. Okay, so DSU doesn't like you don't apply, it doesn't matter it is like contiguous or it discrete. So means, so how DSU I will apply here. So let me tell you. So DSU work in a 1D array. If you ever think like DSU, for DSU require the 1D array. Okay, where the U and B 2 points, we will be connect these 2 points using DSU operation, find by parent and unions, apply the union of these 2 points. But for this 2D array I will try to convert it into a 1D array, so that I can apply the DSU, disjoint set union, as it is expected. Okay, so if you see the two condition, I will utilize this one to converting the 2D, to convert the 2D array into 1D array. So suppose if I have two cell set to be a communicated, if it has one and they are in same column or same row, right? So if you see, if how, if I how I will represent this 2D array index into a 1D array. So first 0 to, if you see how many index required for row, for n is equal to 4. So if you see 0 to 3, right, at 0 3, first 0 to n minus 1 index for row, and I will extend this row 1D array to accumulate this columns index size. I will extend column index from n to the n plus m minus 1 for the column. Okay, so for each cell I will convert into 1D array point, this using this formula I, which is the row plus row size, that is the, let me, if I change it to I plus n, that give the 2 points, means two index value, 2 points in a 1D array corresponding to the cell of 2D array. Okay, this is how will I will apply. So for this one, if you see, let's take this example and try to apply the DSU. So first I will check what calculate the its corresponding 1D array index. Okay, so I have written here I and j. This is corresponding to 2D array. Let me write here 2D to 1D. Okay. So this is 0 0. If I convert into 1D, and row will be pointing to 0, but column index will be pointing to n plus j, which is the size of row plus current index is 0. So that is 4. So I will connect it to point. This is convert into 1D array, and total index it will required n plus m, right? Number of row and number of column, that will be total index will be required. So if I convert this 0 and to 0 and 4, then let's connect it and make it parent of 4 to and 4 to 0, right? This is the parent. Okay, let me just uh, take it another array structure for the rank. So I say, if you haven't watched my DSU concept video, you must watch that first, so that you can connect that concept to the its practical lead code problem. Okay, if let me iterate one by one, like I will iterate 2D matrix. I will first check if it is has one, then I will try to uh, connect that row and column using this one. And similarly, if I go to the from this, this will be need to connected. If I apply the same formula, that will be the I, which is the 1, and n plus j, which is the 5, that connected. 1 and 5. Let me take parent of 1 and 5, right? So this is how it will be get connected. This is 1 and this is 5, and this will be get connected to this one. I need to increase the rank of these two value, right? Then once I get here, I need to connect this one, 1 and 3, correct? 1 and 3. Calculate the 1D array index. What it will give. Let me write here, 1 and 3. It will be 1 and 7, correct? If you find out the, if you connect these 2 point, if you remember finding union of these 2 point, first I will we will find parent of these two, parent of these one itself, and 7 not connected to anyone else, so it pointing to initially itself 7. So I just what I will do, just connect it to which rank have a higher rank. Initially 7 have a lower rank, then attached to it. Okay, so what it have, 7 have somewhere here, right? Let me just put it here, correct? So these all get connected, and once you reach to this cell, then let me just calculate the 3 and 0, correct? And I will calculate the 3 and 4 corresponding to 1D. Let's find out the parent of 3. Parent of 3 is 3 itself, right? Initially 3 itself. Let me point it to 1. Initially it's have a 3, it's have a 2, it's have a 6, all have a 0, right? Initially. Okay, so if you find out the parent of 3 is 3, but parent of 4 is 0. So let me write down here, what is the 3 is itself 3, but rank of 0, parent of 4 is 4 parent is 0, and rank of 0 is higher than the rank of 3. So I will connect to higher one. Okay, so what I need to do, need to update its parent to the 0, correct? Okay, so once you reach here 1, that is the 3 and 3. Now I will calculate the 3 and 7, right? So if you see, find out the parent of 3, that is 0, and find out the parent of 7, that is 1. Now this need to be connected, and both have same rank. 1 have 1 and 0 have 1. We can attach any one of them, but I will attaching to this one. So what I will get, it will get connected to this one. Okay, now all these have a parent 2 pointing to the 0, right? So this have a 0, this have a 0, Okay, and this have a 0. So all this have connected and increase the rank of this one. Okay, so this is how will get connected. Once you have iterate uh, all the cell of all the server present in the grid, then you need to count how I will count for each parent, means each index, who is the parent of that index, and how many servers are connected, that can be counted by, we can increment one by one, and if count is greater than 1, that's the number of server we need to return. Okay, so let's apply into a code. This is, so first I what I will need, I will need a required methods for the DSU. Find parent, right? I will first write, let me write down it first. Parent u and parent u not is equal to u. Just copied my parent. Correct. So in last I just return the parent. Return, sorry, return parent. Correct. And another operation is union. These two operation you will be always applying while you are applying a DSU. Union, where I will require a 2 point that I need to do union for. But for this one, I will require parent and rank, right? And rank. So first I will, as algorithm, I will find out parent of u. So let me find out. I will pass parent. Okay. Similarly, find out the parent of v. Okay, if they are both parent have same value, is pointing to the same, is are already in same group, don't need to do further, just return from here. Else I will calculate the which have a smaller group or a smaller tree, so that I can attach to the larger one. That will tell us by the rank of, rank means size, if you think. So if pu is greater than the rank pv, so I will make a parent of pv to the pu. Correct. Similarly, let me just copy it here. Else operation, just do the reverse one. A parent of u apply to the parent of b. Else, if both have same rank, then we can attach to either anyone. Just, but while attaching, you make sure you also increase the rank of that parent. Okay, so that's the hmm, DSU operation. First, I will what I will require. I will first let me count grid size, total number of row, grid grid dot length, and m is the grid dot length. Okay. First, I will calculate the. It will define the parent. mm, M plus, right? Similarly for the rank. So first I will initialize the parent. So initially each uh, point is pointing to itself, right? I do the I. Okay. So I will apply the first I will start from the 0 to the, let me iterate the grid, and for n is equal to j to 0 to j less than m j plus plus. If any cell grade I and j is equal to 1 means this is the server. I have a server. Then we need to convert into 1D array this cell index I and j need to convert into 1D array so that I can connect, so that I can apply the DSU. So as I discussed, just apply the union operation for these two, I and n plus j, and also require the parent and rank. Okay, once I have visited all the servers, means already have connected by the applying the union operation, let me count it. How many are connected, means how many servers are connected, means communicated, which should have a count greater than 1, right? So how I will do that, let me just n is equal to 0 and start from integer. uh, for this one I also need to, first I will need to calculate the, for each one I will need to calculate the parents for each cell. Once you have connected, apply the union operation. Then for each cell, I will iterate for each one. I will also calculate the parent of each cell. Who is the parent of this one, so that I will able to know they are connected or not. Okay. So require the integer, integer, and connected. So is equal to the new hash map. Okay, so what I will do, first I will find out the uh, I will find out the I will find out the first I will find out the parent of for once you have apply the union operation, then means in this, once you visited all, and at the end you will iterate again and check if who is the parent, right? So you can find out either using the its row, because row and column will be connected for the same cell if they are belong to the same cell, same row and same column or same column. So I will apply, let me find out the parent, find parent, and pass the parent array and I. Okay, for this cell I have used the uh, row index value. Okay, you can use the column also, but while you are using column, you make sure you are thinking in think of 1D. So for this column value you will be using I n plus j. Okay, not only j. Okay, so so I will map dot put for p. Let's count how many index have a parent as a p. So dot get for default p 0 plus 1. Okay, Once we have counted this value, then I have answers is equal to 0 for start from integer and count. I need just a value. Okay. For each parent, for each parent, I need to count that represent the number of connected server. Okay. So values. So if CNT is greater than, it should be greater than single server, don't consider as communicated, right? At least two server need to be uh, communicated. That so there are at least two servers required so that they call to be communicated. Okay. So and last return the answers. Let me run it and see how it works. Yeah, for sample test case, it got passed. Let me submit it for all test case. Yeah, so that's accepted. So this is all about this one. So happy coding. That's it.